Okay, we've looked at proofs with side, 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 angle, side. Now we're going to move on to proofs with our other three conjectures, which are angle, side, angle, 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 side, and hypotenuse leg. So the first one we're going to look at is angle, side, angle. And remember, this is when you have a side that is directly in between the two sets of congruent angles. So if two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then the two triangles have to be congruent. So if you can show those three things, then the triangles have to be congruent. So if you look at this picture, if angle A is congruent to angle D, and then if we know that angle B, has to be a side, sorry. We know that side here, AB, is congruent here to side DE. And then now our second set of angles, angle B, is congruent to angle E. If those three things are true, then our two triangles are congruent. So triangle ABC would be congruent to triangle DEF. Okay, so let's look at some proofs now. So in this first proof, we are given that SQ, this line segment, bisects angle RQT. So RQT is this big angle. So if this line here bisects it, that means it cuts it into two equal parts, two congruent angles. So I'm going to go ahead and mark that in my shape. So I've got this angle is congruent to that angle. Also, it says that SQ bisects angle RST. Well, our angle RST is this angle over here to the right. So if it bisects RST, that means that it cuts it again into two smaller equal angles, which then means that this angle, these two angles right here that I'm marking, are congruent. So let's fill in our proof. We always want to try to fill in our picture with our given information, and that's going to help us at the end determine how we can tell these triangles are congruent. So SQ bisects angle RQT and angle RST. That again is our given information. So angle RQS is congruent to angle TQS. RQS, TQS, they are congruent. And they are congruent because that one angle's been bisected. So that's the definition of an angle bisector. Remember on that very first page of notes, I told you there was a list of things. If you're trying to show that, if you're showing angles congruent, it was either given definition of angle bisector, and there was some parallel line angles. So you got to know those. Definition of angle bisector. If something bisects an angle, then it's an angle bisector. Also, angle RSQ and angle TSQ were congruent. We already marked those. And again, it's because it has been bisected. So that's the definition of an angle bisector. Okay, and then it says that side QS is congruent to side QS. And we've already talked about this. It is, that side is in both of those triangles. So, of course, it's congruent to itself. If something's congruent to itself, it's the same on both sides. Just like looking into the mirror, that is the reflexive property. And therefore, now we have enough parts of these triangles to prove that triangle QRS and triangle QTS are congruent. And what do we have marked in this picture? We have an angle, a side, and an angle. So these are congruent by angle, side, angle. Okay, now let's look at number 2 together. Given that JK and LM are parallel. So if these are parallel, then that means that this line here is a transversal. Remember, if I have parallel lines, that's going to tell me a lot about angles. Okay, so if these are my parallel, this is my transversal. That means that this angle and this angle, oops, not that one. This one over on this side are congruent because they are alternate interiors. Then it says that JL and KM are parallel. So top and bottom, still this is a transversal. So still we have some alternate interior angles. So this angle and this angle, they're both alternate interior angles. Remember, parallel lines always tell us things about or give us extra angles. They don't tell me anything about sides. So filling out our proof here, our two sets of parallel lines is given. Angle JKL and angle MLK, we already have that marked. They're congruent, and we said they're congruent. There was parallel lines cut by a transversal. They were alternate interior angles. That's why they're congruent. Alternate interior angles. Okay. Then we have JLK, angle JLK, and angle MKL are congruent. We have those marked. Again, those were congruent. Parallel lines cut by a transversal. They were also alternate interior angles. And then the final thing in this picture is two angles isn't enough, but they do share this side here. Since that side's in both triangles, so that side KL is going to be congruent to KL. Again, same thing on both sides. That is our reflexive property. And then lastly, now we have enough information to prove these two triangles congruent, and we can do that by angle, side, angle. Okay, now you take just a minute, pause the video, and you try number 3. Okay, going through now number 3 really quickly after you've done worked it. Given angle BAC, so I'm going to mark that, which is this angle, is congruent to angle DEC, which is this angle. So nothing's been filled out on here, so we got to fill everything out. So angle BAC is congruent to angle DEC, and the reason is given. C is the midpoint of AE, is right in the middle, which means AC and EC are going to be congruent, but I'm not going to write that piece of information first. I have to write the given. C is the midpoint of AE, and that was also given. Now, if C is the midpoint, that means that two segments are congruent. Those two segments are what we just marked, so we're going to write that. AC is congruent to EC, okay? And the reason that was the midpoint, therefore these are congruent, is the definition of midpoint. Okay, what else? Let's see. I need one more piece of information. I have a set of angles, a set of sides. There is one more piece of information that we already know, that we've been talking about. These two angles here are congruent because they are vertical angles. So now I just need to name them. And I'm not going to name it C because C is in both. I'm going to name it using 3 letters. So therefore, I can say angle BCA is congruent to angle DCE, and why? Because they are vertical angles. And then finally, I've got enough information and I can prove now. Remember, the last thing's always what you're trying to prove. Triangle ABC is congruent to triangle EDC. And if we look, we've got angle, side, angle. So by angle, side, angle. Okay, the next thing we're going to look at is now proofs with angle, angle, side. So again, two angles, a side. This time the side is not in between the two angles. So here, if angle A is congruent to angle D, an angle, then I have another angle. So if angle B is congruent to angle E, and lastly the side BC is congruent to EF, then my two triangles are triangle ABC is congruent to triangle DEF. Okay, now let's look at a proof using angle, angle, side. So always look at our given YZ bisects angle WYX. So here's YZ, here's angle WYX. So if it bisects it, it cuts it into two equal parts. So we're going to mark that. That angle and that angle are equal. We need to go ahead and write that. That's going to be our first statement. YZ bisects angle WYX. And the reason that is given. Okay, we do have another set of given information, so let's just go ahead and write that. Angle, actually, no, let's go ahead and write what went with this. What did it mean if it bisected it? It gives us two congruent angles. So what are those angles? Angle WYZ is congruent to angle XYZ. And now why is that true? If a side bisects an angle, that is a angle bisector. Okay, now let's do the second piece of given information. Angle YWZ is congruent to angle YXZ. That is given. Then we also need to mark it. So YWZ is that, and then YXZ is that angle. Okay, so we do know that. And that's all of our given information. So what do we still need something else. We do know that we have a set of sides that it shares. So this side, it shares. If that side's in both triangles, that means this left triangle would have WZ in it, and this right triangle would also have WZ in it, or excuse me, YZ. So that means that YZ would be congruent to YZ, and same on both sides. That is the reflexive property. Therefore, I've got enough information so I can prove that triangle, I'm getting that from here, WYZ is congruent to triangle XYZ, and we can do that by angle, angle, side. Okay, let's look at number 5 together. Okay, the first thing on number 5 we're going to start with is our given information. Angle ABC is congruent to angle CED because that was given. And I'm going to mark it. ABC is this one and CED is this one. Okay. We also know that we have a set of parallel lines. AB and CE are parallel. Okay, so AB is parallel to CE. That's another given. Remember, parallel lines tell me angles. Give me more angles. So really quick, if we look at this and let's see if I can see. AB is parallel to CE. Okay, if those are my parallel lines, I have a transversal. Okay, which my transversal, let's see what's going to be my transversal here. This is going to be my transversal.